Hi, I hear it's the end of your day. Here, this is the last session of the day, and I'm so excited that we get to bring the last session to you with this really, really soft, relaxing, easy topic of optimization in Unity. It's
Easy
definitely
and relaxing.
easy and relaxing, nothing
What's
stressful here
never
at
said
all.
before.
My name is Thomas Winkley. I work here at Unity as a technical marketing advocate. I guess I could go to this slide deck, but real quick, let's do a disclaimer. Um, this is a disclaimer about me. I wrote code and I teach. I don't consider myself an optimization expert, but I can definitely share a lot of tips, tricks, and ideas to get you researching and started. Also, while we're doing this session, please do not disparage pizza in the chat. It's delicious, and I'd prefer you didn't do it privately where I don't see it because it'll hurt my feelings. Like I was saying, my name is Thomas Winkley. I'm a senior technical marketing advocate here at Unity Technologies, and I work on the academic and nonprofit team. I guess officially now we're just the education team, which is way easier to say. And then I'm joined by one of my favorite people. Utsav, introduce yourself.
Thanks, Thomas. You're one of my favorite people. Hey, everybody. My name is Utsav. I'm a senior product manager at Unity. I actually used to be a game developer for like 7 years before I moved into product management. I was a consultant at Unity, so I was helping optimize some of our customers' games for like a couple of years before I moved here. So I'm hoping I can shed some light on optimization stuff today.
Yeah, and definitely setting a precursor caveat of like we were actually talking about this backstage before we dove in, right? Like optimization is it's a lot. It's gray area is the wrong way to say it, but like there's a lot of like things you can do to absolutely optimize things and make them run better. And there's lots of tips and tricks, but at the same time, sometimes in the world of optimization, there's trade-offs that you're going to get for doing some of those tips and tricks. So like, it's a process. It's a journey, if you will. It's optimization is about the friends we made along the way. So
That's a good way to put it.
All right, so we're gonna open with our the first tip, and it's it's a lot easier to make small adjustments to your code base and to your game or your project at the end than it is to completely overhaul it or go in and make really deep dive changes. And so I think this is something you've probably experienced a little bit.
Yeah, no, I totally have, and I think it's good to plan for optimization. Obviously, don't go gung ho on optimization the moment you start, but make sure you kind of understand what are you going to build, how is it going to work. You're not going to be building out your whole gameplay in the update function, right? So those kinds of planning ahead of schedule going to yield such good results for you guys.
Yeah, and I think this is good programming practice in general, right? Like the better you can treat future you in your execution of your code early, it's just the better things will work out closer to the end. I think this is in all ways, scalability, modularity. If you were in the session yesterday where we were announcing the winners of the jam and talking with Sorav, that was one of the big things we kept saying was like the favors you do yourself now are really going to pay off later, right? And I think with accessibility, design, optimization, those are always things, right? So while you don't have to be wild about it, you don't, not everything has to be hyper specifically, perfectly, tightly optimal. The more optimal you are early on, the better it's going to be at the end when you're trying to optimize things and really tighten stuff up.
Yeah, and TDDs help. Technical design documents. If you haven't heard of those, go look them up. If you have heard of those, awesome. Continue to use those.
Yep. And if you don't like them, learn to love them. So, all right, let's talk about graphics, or if you believe GIF is pronounced GIF, graphics. So
wow,
that's who I am as a person. All right, so first tip is for small enough meshes, right? You can actually use dynamic batching. So this transforms the vertices on the CPU. It groups many similar vertices together and draws them all in one go. So these are just kind of different types of batching you can utilize. You have static batching, which combines static, non-moving meshes and game objects, and then it renders them faster, right? Because they're one big thing. It can process them. They can move on. But there's some rules when you're using batching. So you've got to share a material. So it's got to be a shared material, not an individual material. Couple notes on there. When you use renderer.material, that creates a copy of the material. Whereas renderer.shared material, you're actually modifying that shared material. So if you've ever run into this where you're trying to like modify a material, I've definitely run into this in like smaller projects or just, it's been a long day. I'm trying to figure stuff out. I got to do a material swap and I do render.material. And then like suddenly my material is not even swapping. I'm like, why isn't it swapping? What's going on, right? It's because render.material makes a copy of that material that you're editing. So render.shared material, that's what you want to target. But when they're using .shared material, that's where, batching is going to be enabled. And there are a lot of other specific rules tied to batching. And there's a docs right here, and I can actually drop this link in the chat for you all. Bloop, 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 bloop. Let me just go up here. Perfect. And then SRP batching using the script to render pipelines. That's script to render pipeline batching. This is shader based rather than material based. Just some notes there. Do you have any thoughts on that, Utsav? Or
Yeah, no, for sure. So for dynamic batching, one of the rules is your word count has to be less than 300 words. So it's actually dynamic batching works great for things like particle effects and maybe canvas UIs or things like that. They can be dynamically batched really well. SRP batching is so powerful. I cannot even tell you how powerful it is, because if you think about it, you can have a single Uber shader create 10 materials in your project, and every static object using that shader, any material, doesn't matter, can be batched together in a single draw call. And when if you ever look through your frame debugger, you'll see that rendering each draw call, how long it takes, and you
Yep.
can see how much of a difference it makes to have all of those batched together. And how SRP batcher works, it really quickly is, what you do is you kind of front load all the variables in your register for where your material data will be stored. And for each material, you just kind of fill in the variables and the properties accordingly, but you never have to update the register with the number of properties for a material. That's what makes it so fast and easy. It's magical, in a way, to be honest.
Yeah, that's super cool, and a huge shout out to the team working on that. Like that, I think that's the thing that always blows my mind. Having the opportunity to work here, like I start learning stuff or talking to a team, and they start going into like what they're building, and I'm like, oh my goodness, y'all are brilliant, and what you're building is amazing. Like it's so exciting. We actually have a question from Vivian asking, do you have optimization tips to avoid generating garbage? I
Yes.
definitely do, and there's some of this presentation. Do you want to run over a couple in off the jump?
Yeah, no, I do. So one biggest thing is cache your data. So if you're in your scene and you need some data to do something that happens when a player does an action, right? So generally what you would do is, if a player does an action, you'd be like, okay, cool, let me get that material data, or let me get that collision data, let me get that data. But what instead you can do is, in your start function or awake function, you can just cache that data in a variable and keep that data cached if you know you're going to be using that data multiple times. Because what happens is, when you try to call that data, or when you try to get access to that data in your update loop, or when something happens, each look up causes some kind of garbage or fragmentation in your memory, right? So
Yep.
caching your data is a great way to avoid kind of generating garbage. Do you have other tips, Thomas?
No, that was basically what I was going to say. I think, in that same vein, object pooling, right, is a massive way to avoid a lot of that, because then you're not going to be instantiating and destroying objects constantly, right? You can initiate everything you need at runtime, or, when you're initializing your app. Unity actually has a really, really powerful object pooling library you can just use. I think that's the right way to describe it. We actually did a Twitch stream together, and we were like, all right, we have to object pool all of our enemies we're going to spawn. I was like, oh boy, I got to write my first, I've got to sit down and write this whole object pooling setup. And then I looked and I was like, wait, I can just, it's literally as easy as like creating your thing and then calling object pool dot, and it just does. It's great. Really powerful stuff. So
Yeah, it is. We also have another question, and I can
yeah.
take that. Is GPU instancing still a thing that's different from dynamic or SRP batching, right? Yes, it is different, and I can briefly tell you how it's different. So batching just means, when you're drawing multiple objects, instead of sending your GPU, a draw call for each of the objects, for example, your character, your environment, your vehicle, whatever it is, right? You're basically rendering them out on a draw call by draw call basis. What GPU instancing does is, you're just copying draw calls. So let's say you are rendering a coin in a collectible, right? Now, instead of batching all the coins together, what you can do is, you can tell the GPU, hey, here's a coin, take this and render it. And then whenever you have to re-render that coin, you're literally just copying that draw call. So that's GPU instancing. Whereas batching means you're batching all the objects, let's say coin, environment, bicycle, you're batching them into a single draw call. So I hope that sheds some light
Okay,
as
so it kind of
to.
separates out the two pieces there.
Yep.
That's actually a good call out. Like I had never considered like the difference between the two options there, and it's really, really good. Yeah, that's okay. Cool.
GPU instancing requires you to have exactly the same material. Like you
Yeah.
cannot have any, not even a single ounce of difference in your materials.
Right. And that's, I mean, that's kind of the definition of instancing, right? Like we see that in a lot of materials in Unity where if it's really convenient, but can also be frustrating if you need to have one material variant, right? Where we generally try to instance all your materials when you're putting, like if you're using one material for 50 objects, if you make a change to that shared material, it is going to in fact impact every one of those objects, right? And that's part of that instancing party. Okay, cool. All right. Let's talk about optimizing UI. So for some folks in this, it might be really common knowledge. I feel like we talk about this quite a lot, but I definitely like to bring this up to folks because it was kind of one of those like light bulbs for me early on in my Unity development career. So Unity renders UI as a mesh, and every time you update the groups of UI, it redraws that mesh, right? So basically, if we have like a heads-up display that has like a life bar and a score, and maybe there's like a little image in the middle, and that image is like a static thing that just makes the UI look cooler. And they're all grouped together, and that score is maybe updating over time. So every frame that score is updating, that means that mesh gets redrawn every frame. Every single frame you're updating that UI. So if you organize your UI with static and dynamic components, that will actually minimize what parts of the UI are being redrawn, which will really help you out, right? So if you have to have that UI update every frame, I would argue that you could probably do an event-based update, but that's a different talk. But like if you have to update it every frame, then that should be on its own as its own little piece of the UI, so that it's only redrawing just that text block or whatever's going on there, and then those two static pieces can stay the same, right? Or if maybe the life bar updates as well, maybe the life bar and the UI and the text score are together, and that static image is its own thing, so that it just gets drawn once and ignored, right? It doesn't have to be thought about anymore.
Yep, and one actually tip I'll give is, instead of using animators for animating instances, like you're like, hey, I just need a single animation, I have a really small UI, just use a tween setup.
Yep.
Tween will only update object transforms and not change any of kind of like your rendering data. So you don't need to re-rasterize your canvas mesh, which means you're not going to redraw your canvas mesh. But you really cannot build an extensive animation system using tweens. You're gonna
Yeah.
have to be like, hey, here's a small thing here, here's a small thing there. If you want something extensive, you gotta separate out dynamic and static objects on UI. That is the best way to move forward.
Yep. I see a question in the chat, and I figured we might as well talk about it now. So how do you avoid the prefab size from becoming gigantic when you use many objects based on a single 3D model? Huh. That's a great question. I'm trying to think about, like, how would you do that?
I
Have you
mean,
got ideas?
yeah, so I think you can do like a nested prefab setup, right? Your primary prefab is like your 3D model, and then your nested prefab kind of walks through the differences in how you're using the 3D model. But my question to you would be, is there a specific reason you're trying to avoid a gigantic prefab? Because large prefabs inherently aren't bad, especially if it's persistent data that is going to be in your scene almost throughout your game. Maybe it's better to keep that prefab loaded into your game because you're not reinstantiating things, you're not changing things.
Mhm.
Sometimes having static content in your game is okay depending on what the use case is. So I would argue, hey, look into why you're concerned about that, and there are genuine reasons to be concerned about that, which is fine. But and then a way to tackle that would be, I would say, nested prefabs would be a great way to kind of get around that and
Mm.
really add some variability.
Cool. Yeah, good answer, because I think there's like more context wanted there, but like, yeah, I think that calls out a grant. Like if you do need a giant prefab, and a giant prefab is the issue, can you just pool it, and instead of instantiating in a shrine, can you just hide it?
Yeah.
Right? You just turn it off and then turn it back on when you need it again. Like there might be options to help like move around it, or like, yeah, I think the nested prefab option is super rad, which is interesting to me, mainly because I just it's silly, but like I remember everybody getting really excited about nested prefabs during like Unity 2017, and now it's like such a common practice. And for whatever reason, like the old man part of my brain is like, well, I remember back in my day when we couldn't nest a prefab. Um, I don't know if you know this, Yusuf. Does this still apply to the new UI toolkit? I'm going to be fully just transparent, John. I haven't done a lot of work with the new UI toolkit yet. So I'm not 100% sure. I need to put aside like a week of my time to play with it, specifically because I'm really excited about how it gives you like, CSS style like layout and everything like that. But I
Yeah.
personally have not spent a lot of time with it, so I don't know the answer to that actually.
Yeah, I have also not spent a lot of time with it, but if my understanding is correct, it's still rasterizing and rendering the same way. The only difference is kind of how you set it up and the versatility CSS offers you to stylize your canvas. So again, I am not sure if this is the answer, but my initial hunch would be that it should work the same way in terms of how it's rendered out.
But I am actually writing a note in my little weekly note of stuff to look into, and that's now on there of like, yeah. Ooh, I like this question from Marcel. What do you mean groups of UI? Like within a canvas, does the entire canvas update if I change anything in it? Yes. So we mean like the hierarchy, right? So yeah, so if you have, so you can, it's if you, yeah. Oh my goodness, my brain just like went
Hey,
hit a wall and
I
rebooted.
can help you
Yeah,
out.
go for it. Yeah,
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 so basically canvas is a root object in your scene, right? So when you're in your hierarchy, you have main camera, which is probably a root object. Any object that is strayed in your hierarchy and is not a child of another parent object is a root object, right? So if your canvas is a single root object, anytime you update something in a canvas, the entire canvas will update. Now, there are two ways to avoid this. One is you add another root component as a canvas and then keep dynamic and static objects separated in two. The other
yeah.
option is to have a sub canvas. So you can have a primary root canvas, but within the root canvas, you can also have sub canvases, and then each canvas would have its own draw call. So I wouldn't recommend this if you only had static UI objects, because then you're just rendering two canvases for
For
nothing,
no
right?
reason. Yeah.
But if you have a couple of dynamic objects and then everything else is static, then you get a sub canvas and then you just re-render the sub canvas every time. So you only have a single root canvas, but then you have a child sub canvas. But it really kind of depends on how you prefer to organize your scene and what makes more sense to you. But just separate dynamic and static elements out.
Into their own canvases, but the canvas
Yep,
is the key of that root organization.
yep. Thank you.
Yeah, no problem. Yeah, I think that's a really good call out there. Make sure we do that, and that'll help you with some optimization stuff. All right, so this is like game dev 101, but sometimes I give this presentation to like brand new game devs. So like reduce your poly count, right? Reduce those triangles. We commonly talk about this as more rendering. More triangles equals more rendering equals lower performance. This is of course subjective, and you may want tons of triangles. We don't need to spend a lot of time on this one. I think everybody in the room, their eyes might have just rolled out of their head. But like again, sometimes I talk to game developers who don't have a lot of experience, and low poly renders quicker.
And LODs.
LODs are a big deal, right? If you want to have something super high impact at close view, LODs will make your life much, much better. All right, let's jump here. All right, another one that might be obvious to some, but not to everybody. When it's possible, bake those lights, right? Put them in the oven, cook them up, let the smell of a warm Christmas light bake waft around your home. You want to make sure that, if you can cook it, do it. Also, cookies, brownies, cakes,
Baking is just fun all around.
Yeah, it's just good for you. But yeah, for those that don't know, baking is pre-calculating, right? So you can basically, any lights that don't need to be dynamic, you don't need to see a shadow cast in certain places, things like that. You can just go ahead and just like caching variables, you can cache that light map, and that makes it a lot faster for a computer to look things up and just go, okay, this is what color this needs to be, this is how this should look, this is the reflectivity, and boom, away you go.
A little very small tidbit if you're interested in more in how light baking works, especially using light probes. Look up what spherical harmonics are, and that's how the light probes work in Unity. It's really cool.
Yeah, light probes are awesome. Big fan. All right, so this is fun because Utsav and I actually had like a little like a discussion last night in Slack because we were kind of just checking in on this, but like use a frame debugger, right? And you heard I mention it earlier. This is technically not an optimization tool, but it will allow you to look through your draw calls in the graphics side of the house and see like what's going on. Do I have overdraw? Are there problems in different areas? Is this draw call drawing the same thing multiple times? Is my batching working the way I want? It really helps you kind of look through that type of information. And that's under window analysis, frame debugger.
Yeah, no, exactly. And it's the same with RenderDoc, right? You use a lot of these tools to optimize, but they're actually debugging tools. And you're like, okay, what's the difference? The difference is when you're debugging, you're trying to figure out, hey, am I rendering the right thing with the right shader, with the right properties and the right data, right? So you're like, okay, if I'm not doing that, then my render is not going to look the way I want it to look. However, those data sets also will give you information on how to optimize your render calls, right? So even though the tool is primarily a debugging tool, the data you can gather from it and the analysis you can do can help you optimize in a very powerful way.
Yep, it gives you just more information to approach like your optimization of your flow and give you that data you want. Okay, it's time for code land. That was all graphical stuff, I guess. And we have 8 minutes left. But again, I loved all the questions that have been coming in. We don't have to get to a certain point of the presentation. So, like, if you have questions, keep throwing them in Q&A. We'll gladly answer them live. So somebody asked, like, hey, how do I reduce garbage? There it is, object pooling. And we already talked about it once. We'll talk about it again. Creating pools of objects to reuse, bullets, collectibles, objects, items. And then you can just manipulate their transform and their state. Makes life a lot easier. It reduces garbage collection and it'll avoid large amounts of instantiation as stuff goes away.
Yeah. And if I don't know if anybody here is a Rider user or not, or if you're a Visual Studio user. Rider has a heap allocator extension that you can use, and that'll tell you anytime you're doing a boxing allocation. Boxing allocation is just when you change types and you kind of reuse data. Changing types creates like another garbage piece because you have your old type and then you have your new type. So it's like your old type is kind of stagnant and is not being used. There's also a question in the chat. And let me read this to you, Thomas. Tell me if you have an idea. When one uses a single 3D model to build an environment, the prefab can become as huge as a gigabyte. That and the scene it's used in
Ooh.
become too large to be supported by free plans for popular version control software. Are there any workarounds for that?
Got you. I see what you're talking about. So you're talking about like actual file size management for compatibility, or for version control and that type of thing. So I've seen a couple of things, and again, like these are just ideas. Please don't take these as gospel. These are just some thoughts. If you have really, really, really large file size, you could store a lot of those really large files on local machine for your development team and only sync certain components of it, right? So you could push like maybe you're only pushing code and then everybody has local instance references of the big files. I've definitely seen things like that done. You could look at reducing the overall size of things, right? Like definitely check for bloat. I've definitely seen it where textures are bloating massively in projects before, and like there's all these extra textures stored that you don't necessarily need, and you can scrub a lot of those out, or you can reduce some of the file size of the textures. Any other thoughts there itself on how we could reduce some of
Yeah,
that big stuff?
a couple. First thing I'll address is, try not to use a single 3D model as a whole environment, because what that does is it doesn't let camera do occlusion rendering, which will improve your performance quite a bit. So
Mm,
try to separate those things out.
that's fair.
Second, there are two things I would consider. One is Git LFS. I don't know if it's free or not. Git LFS is just large file support for Git. You actually kind of need that if you're working with large 3D models. So look into that if you haven't. Within Unity, there are a couple of workarounds you can do. So you can use addressables. So you create an asset bundle through an addressable system, store that on a CDN, and then you make a call to that CDN to inject that model into your game when you're playing the game.
Yep.
However, when you're building the game, how are you going to look into it? You can do like a smaller LOD version of your asset locally and use that and just replace that with the
Yeah.
addressable on the CDN to load that asset. Now, this is a very advanced topic, so I would recommend reading into it before you try something like this. But there are ways you can get around.
Yeah, and I think there's some risks you run with that. Like I know with addressables, like those asset bundles need to be pretty isolated, right? Like they can't be making calls to other bodies of code that are going to be in the initial project. They've got to be their own little unit item optimized units. But all right, what do we? Okay, let's with this next question. What method do you usually prefer for linking objects for use in scripts? Oh, I love this question. Find object with tag and such searches the entire scene, which isn't ideal, and serialized field requires manually assigning it. Singletons are really nice, but only really works for things like managers. I recommend, for me, I try to avoid find object with tag or find game object with tag religiously. So I have the privilege of I do a lot of teaching of beginners. On is kind of a lot of the job I do, and so I definitely see a lot of find object with tag, find game object with tag, and I think again that's fine to use if it's satiating a specific purpose and it's doing what you need it to do. Um, that being said, it is not optimal, right? And as your hierarchy scales, that's going to be a more expensive call. Now, if you're just calling that at start on one object and you never call it again, you're using it to cache, that might actually be a really acceptable way to do it, right? Because you're finding the object, you're throwing it in there, it's cached, it's done. There's a lot of things you can do instead, though. So instead of find object with tag, you could do like a registration system. I might be describing this improperly, so feel free to correct me with the actual terminology. But essentially, you could do something like maybe the enemy needs to know where the player is, right? And you're instantiating the enemies. So maybe when the enemy instantiates, it actually tells the player, "Hey, this is who I am." Like, I'm here, or it registers itself with the game manager and says, "Hey, I'm here." And then the player also has access to the game manager, so it can get that data as it needs. And you're using that manager to centralize that information so that you don't have to do find object with tag, even when you're generating your pool of objects or when you're instantiating an object. What other thoughts do you have, Utsav?
Yeah, no, I think it really depends on the use case. So you're absolutely right, right? If you do a vehicle with get object with tag and cast that value and continue using that value, that's a perfectly fine way to use that find object, in my opinion. And you shouldn't really even worry about it. Another thing you can do is if it's something which is something you're going to continue to use multiple times in your game, you're going to use it, and there's just a very small set of objects you're trying to do it with. Just keep a list, or keep a dictionary, even better, rather than a list, right? And store that value. You get that value in the beginning, or you use a scriptable object, or there are multiple different ways you can do it. But I would say, hey, figure out what your use case is. Singletons for managers is great. Find object with tag for a value you get at the beginning, and cache afterwards is great. Let's say you have interactables. Maybe you use an interface, and then you make sure within the interface everybody, whichever player or enemy needs to know what interactable you're interacting with, can be handled through a single interface.
Yep.
So I would say it depends on your use case, but each of these solutions can fit specifically for what you're trying to do.
Yeah. And again, like, maybe what you're trying to do is you're just like, I just need to know where the player is at start, and that's it. It's one call.
Yeah, and you can still cache that and continue using it.
Exactly. And that's even interesting. It's interesting to think about, but like I was looking into camera.main, right? Because for a long time, optimization tip was never use camera.main. But you know what? We just went and cached that.
Yeah.
So now it's cached by Unity, and camera.main is actually really low overhead because you're just reaching into a cached
basically
runtime, right? Yeah.
And I don't know if anybody, like, I'm sorry if anybody has trouble with what caching is. Caching is just you kind of storing that value on the heap yourself, rather than having to call to the register every time you need that value. That's all caching is.
Yep. And with that, that's actually our next tip. Cache everything. Cache it all. Become a hoarder. Maybe don't be a data hoarder. You should actually not cache everything, because then you're going to cause another problem. But like, store what you need early and then use it as you need it, right? Avoid using GameObject.find, find GameObject with tag, that type of stuff if you can. But again, it's fine to use it if you're using it and you know what you're doing with it and you're not using it heavily, right? If you're putting that in the update method, maybe not. But find the right situation. And if you need to be searching out items, it's better to cache them during load, maybe behind a loading screen, and then have a reference to them as needed, that type of stuff. So, but yeah, I think for you, again, just back to the question, Leon, whatever works best for your situation, right? Because like, honestly, sometimes you don't want to manually drag and drop your stuff in there, but that's not a bad way to do it. And I know it does feel like unprogrammerly. Like I feel that way. I'm like, oh, I'm dragging and dropping. I'm not a real programmer. But you know what? You're caching a variable so you can use it later. You're good.
And you're mostly working with designers and artists, right? You need those tools within your editor to help them do the best work they can do. So I think it's a perfectly fine way to do it.
All right. We're at time. So we only had half an hour, I believe. Oh, we have a minute and 45 left. Okay, cool. We're going to grind. So remove debugs. I use these a lot when I'm testing code, right? Debug.log. I do it all the time. Make sure to remove them to optimize. It's really only an issue if you're calling it a lot. Again, when something doesn't work, I start throwing debugs in to test things. I use breakpoints, debug, and a combination of the few. Pro tip for me, this is something I do. I just have a little debug boolean in my code, and if I need to run debugs, I just do if debug, and boom, that's where my statements log. That way, if I don't want to go back and delete them all, I can just make sure debug is unchecked, and then it's just an if statement that gets skipped.
You can even use a macro, so you don't have to put another boolean. You can do if Unity editor, like literally the entire debug code, you can put it in a macro.
Yep. If Unity editor, give me my debug information. And then that literally, what that will do is it just won't compile when you build your game, because it's like, oh, this is only for the editor instance. The compiler will just ignore it. So another couple great tips there. So this is another one we argued about a little bit, right? We can definitely agree that using coroutines is better than using update. Like that is a universal truth. What's interesting is I did some research into invoke repeating versus coroutines. And the reason I did that is I was doing a code review on a game, and they used a combination of the two. And it was very, very interesting because there's a lot of debate about this. And so I think my advice was like, if you're like, what's interesting in coroutines and invoke repeating, coroutines give you a lot more control, obviously, over the timing, start, stop, all that type of stuff. But I think for your use case, it might, anyone's use case, it would be worth looking at the Unity profiler, which I don't think we'll have time to get into today because we only have 11 seconds, but use the Unity profiler to compare if your coroutine is actually performing worse than an invoke repeating. And if so, then just use the invoke repeating, especially if you don't need a lot of control over it. But we could go way deeper down this rabbit hole for sure.
Yep, I see you already have delegate events, async functions, tasks, jobs, depending on what packages and things you're using. So, but just don't put everything in update is the main takeaway.
Do not do it. Unless you really want to make yourself cry. It's funny. He knows when it happens too. He has a psychic power. He cries every day at least once because somebody has done it, and he just starts to cry and he doesn't know why. But that's why.
Yeah, it's true. It's true.
Awesome. Thank you all for coming and hanging out with us. I realize this is the end of the day and we're hitting you with an optimization talk. So you're like already a little tired, and we're like, all right, let's get gritty. But I hope you enjoyed it. I hope you learned a ton. Huge thank you to Oleg and the whole team for having us here. It's always fun presenting with you, and I hope you all have a wonderful in-person. I guess there's an in-person piece going on for this, so if you're going to the in-person stuff, I hope you enjoy it, and you all be well.
Thank you, guys. Thank you so much.
We'll see you.